All right, so today we're going to be talking about, let me mic myself up. All right, 2.5, 2020. So our primary objective is going to be to connect reasoning and algebra and geometry. So you're going to know this from your time in Algebra 1 and before that, a lot of it's, but we're just going to give them formal names. So the addition property of equality. If A equals B, then, come on, give me a pen that works here. All right, there we go. Then A plus C equals B plus C. All right, and basically what we're doing is we're saying if we add the same number to equal terms, the result is going to be equal. Now, subtraction, same thing, except instead of plus, it's going to be minus. Multiplication, AC equals BC. And division, A divided by C is equal to B divided by C with the one disclaimer, C cannot be equal to 0. Remember, we cannot divide a number by 0. Okay, the reflexive property, A is equal to A. What we're saying is something's equal to itself. It may seem silly now, but when we get into geometry and shared sides, that will come to help us a lot. Symmetric property, if A equals B, then B equals A. So whatever side on the equal sign they are doesn't affect their equality. Transitive property, this is where things get useful. If A equals B and B equals C, then A is equal to C. Basically what we're saying is if two things are equal to the same thing, then they're equal to each other. And then finally, substitution is written underneath. If A equals B, then B can replace A in any equation. And you're going to use this whenever you're working with an algebraic situation and you substitute the variable expression for the geometric statement of congruence or equality. All right, so here's what we got. So you get the idea of a structure with a proof with something you've already seen in algebra. 5x plus 1 is equal to 21. So if this was an algebra class, you asked to solve it, you would subtract 1 from both sides. All right, and x equals 4. So there's our proof. All right, so every good proof starts with what they tell you. So you restate what is called the given. So 5x plus 1 is equal to 21. Now, you don't necessarily have to show your work, but you do have to show your results. So 5x is equal to 20. All right. Now, we've talked about abbreviating things this week. Subtraction and substitution are one of the things you cannot abbreviate, okay, because they both start with SUB. So basically, those are the only two you have to write out. Feel free to abbreviate with the word prop for property. And then finally, x equals 4. All right, that you can abbreviate division property because there isn't anything like that. All right, so we're just formalizing what you've already done. All right, next up, now we add a little bit of geometry. Prove the measure of angle AOA equals 130. So we start with what they give us, which is a straight line. All right, we're allowed to assume a straight line is straight, which gives us a linear pair. All right, so we can say AOC, AO and C are collinear. Reason it is given. Okay. Then you can say the measure of angle AOM plus the measure of angle MOC equals 180. Okay? Linear pair property. Remember, if two angles form a linear pair, they are supplementary. 2x plus 30 plus x equals 180. All right, that is going to be the substitution property. All right, that is the substitution property. So basically, anytime you replace a geometric property with a variable expression, that's what you do. So 2x plus 1x is 3x. 3x plus 30 equals 180. All right, you can put collect like terms if you want. All right, 3x equals 50. Subtraction property. 3x equals 150. I apologize. and x equals 50, division property. All right, now we go back. All right, we're going to need another line over here. I apologize. We're running out of room. That's my fault. I didn't leave enough. All right. So basically, once you solve for the variable and x equals 50, now we're trying to get MOA, which is this angle here. 2 times 50 plus 30 equals 130. Again, that's substitution because we're replacing a variable with a value that we know it's equivalent to. All right. If we look at the next one, you try one. Prove the measure of angle NAR is 150. So AB bisects angle RAN. Given. Now, here's something you need to know, and the reason why we told you the angles can be named with numbers. If it's easier for you, all right, in this situation, if you want to give them numbers, 1 and 2, feel free to. So angle 1 is congruent to angle 2. Proofs are going to be hard enough. We're going to try to make it easy for you. So definition of angle bisector. Now angle 1 is the x, and then the angle 2 is 2x minus 75. Again, we're replacing geometric terms with algebraic expressions. The best bet you can go with is substitution property. All right. Now, you can the easiest way is probably to bring the 2x over to the other side. Negative x equals negative 75. That would be subtraction property. And then x equals 75. All right. Now, here's the point I'm going to make, multiplication property. I could have gone with division property as well. So anytime you could have used subtraction, you can use addition. Anytime you could have used multiplication, you can use division. So they're interchangeable. Now, once you know x is 75, okay, angle NAR equals 75, which is the x there, plus 2 times 75 minus 75. All right, they're going to cancel out. I'm left with 2 times 75, which is 150, and again, that would be substitution. Okay. One thing I am going to remind you of before moving on other things, and that's what we call the angle addition postulate. That states that if a point is located in the interior of an angle, then the sum of the two angles, getting choked up, created by connecting the vertex to the point where the ray is equal to the original angle. It's a lot there. Here's what I'm going to tell you. If you have this diagram, all right, that's angle A. And when you set up your proof, you want to say angle 1 plus the measure of angle 2 equals the measure of angle A. All you do is, when you give your reason, angle addition postulate. All right? Doesn't have to be anything fancier than that. All right? So basically, when you include in the proof, that's what you're going to do. All right. Now, properties of congruence on the other side. Some of these are going to be repetitive, but the reflexive property of congruence says that AB is congruent to AB and angle A is congruent to angle A. If AB is congruent to CD, then CD is congruent to AD. If angle A, it should be AB. Sorry about that. That's a misprint. All right. That is going to be symmetric, which means we can change the order. If AB is congruent to CD and EF is congruent to CD, then AB is congruent to EF. That's the transitive property of congruence. Again, basically, if two things are equal to the same thing, they are equal to each other. Now, the difference between these and the previous one, same names, we use these when we talk about geometric figures and not numerical values. All right? So you have to explain that. Basically, when you have an equal sign, you're going to use equality. When you have a congruent sign, you're going to use congruence. All right? So 2x plus 9 equals 19, and 2x equals 10. That would be subtraction property of equality. It's an equal sign. O is congruent to W, and W is congruent to L, then O is congruent to L. That's the transitive property of congruence. And then finally, if the measure of angle L is equal to measure of angle E, then the measure of angle E equals the measure of angle L. That would be symmetric property of equality. All right, which leads us to our final thing of the day, proofs, a convincing argument that uses deductive reasoning. Inductive is what we did in 2.1. We look at patterns. Deductive reasoning is the basis of all algebra. It's basically what allows us to say that, all right, two things are true without having to go through experiment after experiment. These can be, they can be in two-column, which most people do, flowchart format, which we'll show you, or paragraph, which means you write it out. Basically, you take the given information and list statements of congruence or equality based upon the definitions. So, we'll start with this one. I'm going to do this one in two-column format. Okay? And it says Li bisects FLD. All right? So Li is this one, FLD is that angle. So I would tell you to label the angles congruent right away. Given. Which means angle 1 is congruent to angle 2. Definition of angle bisector. LD bisects ULI. So that's this one. ULI is that one. So those angles are congruent. So LD bisects angle ULI. That is given. And angle 2 is congruent to angle 3. Definition of angle bisector. If you would like to group things together, feel free. So for example, if you put these two together and said they're both given in the same statement, fine. Same with those. Well, angle 1 is congruent to angle 2, 2 is congruent to angle 3. You realize that the same angles in both. Well, that means we can take the other angles listed, angle 1 and angle 3, and say they are congruent by the transitive property of congruence. All right. A very similar problem. It says AB is congruent to CD. Prove AC is congruent to BD. Now, you're not going to do this every time, but let's use some numbers to help validate. So that's 3 and that's 3, and let's say that's 4. AC would be 3 plus 4, which is 7. DB would be 3 plus 4, which is 7, and you notice they're exactly the same. If instead of numbers, I make them variables. And again, you don't have to do this every time, but this just validates it. That would be X, that would be X, and this is Y. AC would be X plus Y. DB would be X plus Y. You'll notice they're exactly the same. All right, so AB is congruent to CD. Given. Okay. Well, this one's pretty easy. Here's what we're going to do. We're going to say AC is congruent to BD. And here's one of the statements. Whenever you use this idea that we're adding the same segment, adding the same segment to congruent segments results in congruent segments. All right, so these are the beginning of proofs, okay? These are the beginnings of proofs. We're going to use those in the next couple sections, 2.5 and 2.6. And then we will quiz you on that. And then when we get into chapter 3, we'll get away from it for a second, but then we'll come back to them, and then it'll really begin in earnest. Chapter 4. So this is something you really want to pay attention to over the next couple weeks. All right? Be good, everybody. Be safe. Have a good one.